Hello good people, welcome to InspectBits, Episode 8, GFCI Devices. Gary Gentry here with Quality Residential Inspections in Raleigh, North Carolina. One of the common defects that we find during home inspections is defective GFCI devices. GFCI is an acronym for Ground Fault Circuit Interrupter, and what we often find is that they're simply not properly functional or that they've been physically damaged in some way. A GFCI device is usually a receptacle mounted in a wall box, or a breaker installed in a primary distribution subpanel, or at a main service panel, and both have integral test functions. GFCI devices help protect people in the event that people, water, and electricity might happen to get together for a party at the same time. Not really an ideal combination. They function as safety devices by sensing an increase in the flow of electric current, as little as 5 milliamps, and that's not very much, and by shutting off the power at that location or at all locations downstream of the device. To give you an example, as little as 1 milliamp can be fatal depending on voltage and other conditions. You can think of the device as shutting off the power if it senses a leak of electricity, what we refer to as a ground fault. Very simply, the devices function by sensing the amount of electricity going in on the black or the hot wire and comparing that to the amount of electricity that's leaving on the white or the neutral wire. If there's any significant difference, then the electricity is leaking somewhere. If the leak's the result of electricity coursing through your body, which wouldn't be a good thing, then the GFCI device may not have precluded experiencing a most shocking event, but it likely prevented you from being electrocuted. Electricity is like a lot of people. It's going to follow the path of least resistance. It'll go where it's easiest for it to go. So if you come in contact with any of that leaky electricity and provide less resistance than the wires do, then it would rather follow your path than the intended path along the wiring. Put another way, the person may be a better route to ground for the electricity because they're less insulated. Today, and in most jurisdictions, GFCI protection is required generally for bathroom outlets, for exterior outlets, at kitchen area outlets, and for whirlpool tub motor circuits. Other required locations might be at outlets near swimming pools, and there might be other places as well. We often get asked during a home inspection, well, you just told me that this receptacle is GFCI protected, but there isn't any test button at that receptacle. Why is that? And a good question it is. There are various ways to provide the intended protection at any particular location. We could install a GFCI receptacle at every location where protection is required, but that would be expensive and wouldn't be really practical. Or we can install one GFCI receptacle to protect an entire circuit or series of receptacles. Or we could just install a GFCI breaker at an electrical panel to provide the desired protection to an entire circuit. Another question that's often posed is, can I install GFCIs in an older house? Usually, with regards to this discussion anyway, an older home would be one that was initially wired using two-conductor wiring and where there is no third ground wire. The simple answer is yes, you can, although it's likely not as safe and effective as a device installed on a three-conductor circuit where there is a direct path to ground through the electrical panel. It's probably safe to say, though, that a two-conductor circuit protected by a GFCI device is safer than one that's not protected. We also get asked how often these GFCI devices need to be tested. Well, the manufacturers typically recommend that they be tested every 30 days. I'm going to go out on a limb here and say that if you were to test yours a couple of times a year, then you'd be doing so far more often than most people. And testing the devices is an important aspect of keeping them in good working order and in verifying that they still do what they're designed to do. To test a receptacle device, simply push the test button and then the reset button to restore the power. In the instance of a breaker-based device, push the test button, move the breaker lever from the tripped position to the off position, and then return it to its on position. If the device fails to respond to a manual test or won't allow you to move it out of the trip position, then consult a licensed electrician to evaluate the issue and replace the device as needed. As usual, we hope you found this episode of InspectBits interesting. Leave us a comment, rate our videos, or drop us a line and let us know what you think, or if there's a particular topic that you might be interested in hearing about. Check back with us soon for our next episode 9, where our topic will be hazards associated with performing a home inspection, or home inspection safety. Thank you so very much for your time. Make it a great one no matter what it might be, and remember, when it comes to houses, you just never know.